Hi, everybody. We are going to review what we talked about before the Thanksgiving break, just so that we start off these next couple of weeks off strong. So we were talking about systems of equations, and we talked about two different ways to solve a systems of equations. So first, I just want to speak about what our three different possible solutions are. So you can have a situation where you have exactly one solution, which occurs where those two lines cross each other, where those two equations have a point in common or an x and y value in common. So your answer is always going to be a location. It's always going to be an x and y value. The second possibility is if you have infinite solutions, and a system of equations is made up of two or more equations. Well, I only see one line here. And so this occurs when you have the exact same line or the exact same equation. It's identical, it's sitting on top of itself, and so they're always going to be touching, they're always going to be interacting. So they have infinite solutions. So again, this happens when they have the same equation or line. And so you might have two equations that look different because they're in a different format. So one might be in slope-intercept form, one might be in point-slope form, or one might be in standard form. And so they look different, but they are actually representing the same thing. And then our third type is when we have no solutions, and if we notice these two lines don't cross, they are parallel. So they're never going to intersect, they're never going to cross, so they don't have any points in common. And remember, when they're parallel, they have the same slope. So that's something we can keep an eye out for, is you can quickly notice if two lines have the same slope, and you can just be like, oh, this is going to be no solutions. So the two different ways that we learned how to solve a system of equations. First, we talked about graphing. And so with graphing, we're just going to graph our two lines and see if they intersect. So I'm going to start off with the first equation here. This first equation, we are going to need to look for the y-intercept. There we go. And the y-intercept is our b value, or the number that's by itself. And so it's at 3, which the location of that on the coordinate plane is 0, 3. It's when your x is equal to 0. So I'm going to put a point at 0, 3 right here. And then we're going to use the slope. And the slope is the number in front of the x. If I don't see a number there, it is going to be a 1. So our slope is 1. And when we're graphing, we utilize this as a rise over run. So this means we are going to rise up 1, and then we are going to run to the right 1. So from my graphed point of 0, 3, I'm going to go up 1 and to the right 1, up 1 to the right 1. I'm going to do this continually and make a couple of points that I'm going to connect for my line. Okay. And then I am going to connect those, and you can use a ruler if you want, or the side of a piece of paper, or like your ID, the ID that you have to wear at school. Like, you can use that edge to make a nice straight line if you would like to. Otherwise, just roughly sketch it as best as you can. So that is our first equation. Then we are going to do the second equation. So I'm going to write the information about that here. So y equals 2x plus 5. My y-intercept for that equation is 5. So it's going to be at 0, 5. So that's the first point I'm going to plot, 0, 5. And then the slope is 2. And so that means I'm going to rise up 2 and run to the right 1. So up 2 to the right 1, up 2 to the right 1. And if you want to make dots in the opposite direction, you make the complete opposite movement. So instead of up 2 and to the right 1, we're going to go down 2 and to the left 1, down 2 and to the left 1, down 2 and to the left 1. So we can start to see our line take shape. I am going to connect my points, adjust my fancy line here. There we go. And so we are going to look at where our lines intersect. Our lines intersect In that circled space, the location of that is the x value of -2 and the y value of 1. So our solution is -2, 1. That is solving with graphing. Next, we're going to look at solving with substitution, which is our second technique that we learned. When we solve with substitution, we are trying to take a variable such as y here. Y is completely equal to x plus 1. So that means anywhere I see the letter y, I can replace it with x plus 1. So in my second equation, I have a y. I can replace the whole thing with x plus 1. I'm going to do so with parentheses in case I have to deal with distribution of a number or negative symbol. It's just a best practice to use. So I'm going to rewrite the second equation. So I have 4x plus, and then when y happens, I'm going to put parentheses. I'm going to plug in or substitute in the x plus 1, close parentheses, and continue the equation equals 6. Now that addition symbol in front of the parentheses has a 1 behind it. That doesn't change anything. There's nothing to distribute into the parentheses, so I can get rid of the parentheses now. So we have 4x plus x plus 1 equals 6. Now our goal is to combine like terms and solve for x. So 4x plus x gives us a total of 5x plus 1 equals 6. I am going to subtract 1 on both sides to get 5x by itself. And so we have 5x equals 6 minus 1 is 5. And then to get x alone, I am going to divide by 5. And x will be equal to 1. So now that we have x is equal to 1, we're not done, but this gives us the first part of our answer. So remember, our answer is going to be an ordered pair. So the first part is 1. Now we're going to take that x value and we are going to plug it back into one of my two equations. So we're going to plug in x equals 1, and I'm going to plug it into the first equation. You can plug it into either one. You should still get the same answer both times. I just look at which equation is easier looking to manage. Do I have a lot of multiplication or distribution happening? And so the first equation looks nice and easy. It says y equals x plus 1. So where I see x, I'm going to replace it with 1. So we have y equals 1 plus 1. 1 plus 1 is 2. 1 plus 1 is 2. So my y value is 2.